We're going to start right here at the Winspear Opera House, and it's a great place to begin a math tour because we'll see that the architects, Foster and Company, were literally playing with numbers when they built this structure. And there's lots of different mathematical characteristics. If you ever happen to get a view from above the city, you'll see there's a giant hexagon in the sky on the roof of that. We can't really see it from here, so we're just going to start with one aspect of the building that you can see very well from right here, which are these louvers up overhead. And you might expect, for example, that in a grid like this, you'd see the same number of louvers in every rectangle, but as you look around, you'll see that's obviously not the case. So we're going to try to take a little look at what's going on there. If you look at adjacent cells, so they have these rectangles that got a long direction and they've got a short direction. The short direction is the length of the louver. So look at ones that are side by side along one of their long edges in terms of these rectangular cells up above. What do you notice about the louvers between two cells?
They vary.
Yep, obviously we're seeing different numbers of louvers in different cells. What else do we see? So in some cases, if they close, they would actually touch. So not in like the cell over there that only has 2 louvers. Those are never going to touch. But in some of these other cells, they might touch or even overlap. Yeah, excellent observation. What else do you notice about louvers in 2 adjacent cells?
They're attached to the same position.
Exactly. Anytime you've got one louver, if there's more louvers in the next cell, the ones from where there's fewer louvers go right through and attach in the same axis. So that actually tells us something about the numbers of louvers that could appear, because each one of those louvers from the cell that has fewer goes straight through. So I'm going to draw on here as if I had a couple of cells. So here's one cell, and here's the next cell. And like if I take this one that's got 3 louvers across, well, we know these continue. So we're going to have at least 3 louvers over here. And so you'll see there's 3 and then 3. But then there's more in the next cell. And how many more? Could it be an arbitrary number of more? What do you notice about the way the louvers extend into the next cell?
They're in between them.
It's always in between, and I heard doubles. So now if I put one louver in between each of these louvers over in this cell, will that double the number? In other words, does it go from 3 to 6? Take a look up there. 7. Why does it go from 3 to 7 if you're putting one in between each? Why wouldn't that be double? Yeah, because if you draw 3 lines in a rectangle, it breaks it up into 1, 2, 3, 4 spaces. So you actually will be getting 3, if I want to do it here, you'll be getting 3 plus 4 times 1. Where did that 1 come from? Because you added 1 in every space. Can anybody see a place where a different pattern was used to move from one cell to the next? Yeah, what do you see over there? Yeah, inserting tube in every space. So we'll start over here with 2, and then what happened is those continue into the next cell, and we have 2 added in every spot. Okay, and so now we get the number pattern that we go from 2 to 2 plus 3 times 2, which is equal to what? It looks like 8. Okay, excellent. And you'll see, if you look here close to the building, the same thing is done with 3 of them. Okay, where these continue, and then we add 2 between every one of those. And so now we're going to get 3 plus 4 times 2, which is what? 11. Excellent. But now if you look way down at the other end, we take these 11 and it actually lines up with 5 on the other side. And we put 1 in between each. So we can see from this direction we're getting 5 plus 6 times 1 also equals 11. So you can see that the architects are playing with numbers and different ways of breaking down the same number using simple elementary arithmetic. So it's kind of fun to see how we start with 5 on one side and 3 on the other, and then using these 2 different ways of sticking extra slats in the middle, we come together to form the number 11 in the center. So I think that's something that the folks here will enjoy, to think about the different patterns of numbers that were used to create this building.